So this week we're going to talk about script files, and we're going to spend most of our time on functions. So just an overview of a script file. It's what we've already been using. The script files are written, edited, saved, and executed using the editor window. So here's what MATLAB looks like. If you want to create a new script file, you can go New, Script. But it's what we've been doing in lecture already. So here's our script file from lecture. You can see it's separated in its own code. You can run it, you can run section, you can look at it in the command window. These files are .m files, and in order for you to run it, they have to be in your current folder. So here's the file example week.1.m. So it's an M file, it's in my current folder. Naming script files is the same as naming variables, so they need to be named with letters, numbers, and underscores. Just like with variables, just like with files, same thing. Every time you run it, it automatically saves, but every time you make a change, you do need to save it before you run it. And you'll notice it's unsaved if there's an asterisk next to it. Okay, so that's what you'll be using for your homework. Most of this week is going to be focused on functions, where a function is a script file that's an isolated set of code that executes a specific purpose given specific inputs, then returns a corresponding result, so a specific result. You can think of it like a math function, where if I have f of x equals 3x plus 7, that's a specific function to calculate a specific number given a specific value of x. And if I plug in a specific value of x, I will get a specific y value. And there's reasons why we write functions. Our code can get really long. Functions help us separate it into smaller problems. It maximizes reusing pre-existing code so we can use it over and over again. And then it simplifies debugging because it helps isolate our code so we can debug it one piece at a time. But like I said, it's just a script file that defines a function. So to create a new function file, you can go to new script. You can also go to new function. Either one, I will probably just do a script file in class. But here is a template for a new function. And the only difference between this and creating a new script file is literally just not having to type this out versus having to type it out. But it's just a script file, so when you save a function, it saves as a .m file. The only difference is you cannot run a function file. So script files you can run, function files cannot run. You need to call a function file. And once again, it needs to appear in the current folder in order for you to use it and call it. So let's look at the function. Here's a template for a function. You can see it matches what we have over here. Functions always begin with the word function. This indicates that it is a function file. This first line here is called the function definition line. It identifies the input parameters, so these are my inputs. It identifies my outputs and the name of the function. So that one line of code is super important. It tells us so much about the function. Below that, we have what's called an H1 line. So the H1 line has the name of the function in all caps. It's bolded. That's comment for bold. And then a short one-line summary of what the function does. Below that, we have our help text lines. So I have it more explained out in my document over here, but it's just detailed explanation. So I like to make sure that we identify the use case. So how do I use the function? How do I call the function? And then a description of what the inputs are and what the outputs are. So my inputs here mean something. So what are the different variables that my inputs are? What do they mean? What are the units associated with it, etc. And then in this part here, here's where our code goes. That's where our code goes. And then every function has an end. So this end corresponds to the function. And just so we can say, it's done. So all functions have an end. So that's all the pieces of our function. So let's go ahead and look at a function. I'm going to pull it up over here, and we're going to talk through it. So this is my gravitational force function. It's named gravitational force. It has 3 input parameters, mass 1, mass 2, and distance. It has 1 output parameter, force. All of that just by the function definition line. I can see the name, I can see the inputs, and I can see the output. So these inputs are described in my help text lines. This output is described in my help text line. The purpose of the function is described in this H1 line, and the use of the function is described right here. So here's all my documentation that says that the gravitational force function calculates Newton's law of universal gravitation. The use case is right here. How do I use this function? How do I call this function? What is the order of my inputs? What is the order of my outputs? What's the name of my function? The inputs then are described as mass 1, which is the mass of the first object in kilograms, important. Mass 2 is the mass of the second object in kilograms, also important. And then distance is the distance between the 2 objects' centers of mass in meters. And my output is the calculated gravitational force in newtons. So all of this tells me all I need to know about this function. Then here's my function body. It has 2 lines of code. Notice, I'm going to point this out on my paper here. My inputs here, mass 1, mass 2, and distance, these are used in my calculations. Mass 1 is used, mass 2 is used, and distance is used. They are not defined. Nowhere do I say mass 1 equals, mass 2 equals, distance equals. That will come later. Force here is assigned. A variable named force is assigned in my function that corresponds to whatever is going to be output. So that's super important to note. Okay. There are 4 main steps to help simplify the process of writing a function. So I have them written over here. 1, identify what the function will do. Start by writing some code. Start by writing the function body. The input parameters are going to be identified as the variables that are used in your calculations. The output parameters are the variables that are defined by the calculations. So if I go back to my function over here, mass 1, mass 2, and distance are used in the calculations. Force is assigned. That's what I want to calculate. The function body can contain anything else, any valid MATLAB code. Literally anything can go in a function that is valid MATLAB code. So based on the function body, then you're going to go ahead and figure out, okay, what's a descriptive name for the function? Functions need to be named just like variables, letters, numbers, and underscores. Okay, we'll see that pattern a couple times. Functions need to be named like that. Variables need to be named like that. Files need to be named like that. But we'll figure out a descriptive name. For this function, gravitational force. Descriptive enough. I could have put an underscore in here. Totally fine. Name it however. But it should be descriptive. Then determine what the input parameters are. So go back up here and look at your function body and look at, okay, what variables are needed in order to perform these calculations? They are not defined in the function body. At no point do we say input 1 equals something. At no point. Okay, they are just used they're just used in the calculations. Ask yourself, what changes? What would change in this calculation? Over here, gravity doesn't change. That doesn't need to be an input. But mass 1, mass 2, and distance, those can change. So they should be inputs. And you can have as many inputs as you want. 0, 1, 2, 3, 4, 7, 20, 1,000, however many you want. Just make it practical. And then once again, we can go up here. We can say, okay, what are my output parameters? What is defined by my calculations? What is my final calculation going to be? Over here, I want to calculate the force. That's a good indicator. It's going to be my output parameter. They determine what essential data is returned from the function. So you can have more than one thing being calculated, but think back to our problem where we had calculations for R in lecture. We had R1 equaled something. We had R2 equaled something. We had R3 equals something. But R was our final calculation. That was R1 times R2 plus R3 or something along those lines. Okay, so this would be our final output. These ones are just intermediate variables that help us break things up. Okay, so think about what's your final calculation. And you can have as many outputs as you want as well. 0, 1, 2, 3, 4, 15, 1,000, same thing. Just make it reasonable. And usually when we're writing functions in this class, I will tell you exactly what the input parameters are going to be and what the output parameters are going to be and what your function name is going to be. So usually I'm going to give you that entire first function definition line. So that is how we go ahead and approach writing a function. Okay, the difference, like I said before, between a function and a script file is that function files cannot be run. I cannot press run here. It will give me an error. It will say something like this: not enough input arguments. Because a function cannot be run, it needs to be called. So function call, you will hear that word a lot. It's an expression, so it's a line of code that executes the code inside of a function by defining what the input arguments are going to be and assigning the output argument. So input parameters are created when we write our function. Input arguments are used when we call our function. And we can call our function from the command window. We can call it from another script file. It does not matter. Okay? So I'm going to go ahead and call this gravitational force function. And we call them the same way we called our math functions. So built-in MATLAB functions, like all of our math functions, same thing. That's, you called a function by calling the sine function, or tan d of 15 degrees. That's calling a function. Here is your input argument. Ants, I didn't say ants equals, but ants is your output argument. So if I want to call this gravitational force function, I'm going to create a variable. So f equals, I'm going to create a variable that's used to store whatever my final output is. So force, whatever a force is calculated as, is going to be assigned to f. And then I call the name of my function, or I write the name of my function, gravitational, just like I used the tan d, I called the tan d function. And then here I'm going to give the function some data. I'm going to give it a value to use for mass 1. Oh no, 10e to the 6. I'm going to give it a value to use for mass 2, 10e to the 8. And then I'm going to give it a distance between those two objects. 3e to the 15. I don't know. Just values. When I press enter, what's going to happen is these input values are going to be used for these input parameters. So 10e to the 6 is used for mass 1. 10e to the 8 is used for mass 2. 3e to the 15 is used for distance. So those three numbers are then going to be used in this calculation. Force is going to be given a value and is going to be returned or assigned to whatever my output variable is here, whatever my output argument is here. So f stores this, which was calculated for force. So input arguments are just variables or values. Oops. They're just variables or values. They are, or expressions. Honestly, I could have done 5 times. I could have done 10 times 10 raised to the 6. This is totally fine. It's an expression. But anything can go here. Any valid MATLAB code can be used as my input argument. So it can be used to assign a value to mass. I can use variables that exist in here. So I could use mass as well. And it'll use whatever is stored in my workspace for mass. Note, this mass is different than this mass. This mass here is in my workspace. This mass here is in my function. And then output arguments are just variables that I'm defining to store the output answer. In order to call a function, it needs to be in my current folder. So gravitational force needs to be in my current folder, and you can see that it is. So when we call a function, we're going to ask ourselves a couple things. We're going to ask ourselves, what function do I want to use? Do I want to use the gravitational force function? Do I want to use the nth root function? Either way, doesn't matter. What is the name of my function? Then I'm going to ask, how many input parameters do I have? Nth root has two input parameters. It has an x value and an n value, whatever's under the radical and whatever power I'm using for that radical. And then I ask, what values do I want those to be? So what's in my radical? 23. What's my nth root? 5. And then lastly, how many output parameters does it have? All of our math functions have one output. Y equals whatever I want to store my output in. I want to store it in a variable called y. Or maybe I want to store it in a variable called out. Doesn't matter. Same thing here. This has one output. So I only had f. When I press enter, it's going to go ahead and use 23 for x. It's going to use 5 for n, do the calculations, and then give me whatever the final calculation was. Okay. There's a common error where students provide too many input or output arguments. And note, when you are running a function, not enough input arguments. You didn't tell it what mass 1, mass 2, and distance are going to be. Okay, so that's kind of important. So make sure you pay attention to how many input arguments there are for a function that you're using and what order they're in. So make sure you also pay attention to the order. So the function must be called in the appropriate order and provide the right number. I'm going to skip over this. We'll talk about this in class. Okay, so the last thing I wanted to mention for this video is that a function is an isolated set of code. An isolated set of code. So all of this is self-contained. Mass 1, mass 2, distance, g, force, all of these exist only in the function. So the variables created inside the function are inaccessible from anywhere else. A function has its own workspace. It has its own local workspace. That's super important. The command window and your script files are in the global workspace. So this here is my global workspace. Notice I called my gravitational force function. I called it. It has variables, mass 1, mass 2, and distance, and force, and g. Those are variables. Some of them are my input parameters, some of them are my output parameters, but they're variables. Notice none of these variables show up in my workspace because my function has its own separated workspace behind the scenes. My input parameters for my workspace are assigned when I call my function. So mass gets a value of 10e to the 6. Mass 2 gets a value of 10e to the 8. Distance gets a value of 3e to the 15. But that only happens when I call my function. I can call my function with different values. I can call it with 23, 45, and 1. It will use different values. Here, mass 1 used a value of 23. Mass 2 used a value of 45. Distance used a value of 1. Okay, so every time you call a function, different values are assigned according to the function input arguments. Same thing with the output arguments. I can call my function multiple times. So I can call this f1. I can store my calculations in different variables. It doesn't matter what force is, because force is just existent inside of my function. So they're assigned, once again, according to the function output parameters. So whatever force is copied into f here. Whatever force is copied into f1 here. The reason for this is it minimizes what's called side effects. It minimizes unintentional changes. It just really helps with isolating things, debugging things. If this function works, I know that there's not going to be a problem with this function. Okay, the last thing to mention is there are a lot of built-in MATLAB functions. So I just want to briefly go over different ways we can find help and figure out which MATLAB functions we can use. So the first one is the help icon on the home tab. So there is, on the home tab, there's a help icon. You can click on this. It'll open up the MATLAB documentation. You can search just like in Google. You can look at all the different things you have access to, looking at MATLAB, getting started. There's a lot of help resources there. So that's the first thing. The second one is you can go ahead and use a function. So let's say I'm looking at the tan-d function. You can double click it. You can double click it, right click on it, and say help on selection. So help on selection, it'll open up a little window that shows you, oh, the tan-d function does this. So if we look at nth root, we can see returns the real nth root of the elements, which makes it a little bit different than raising a number to a fractional power. So we can read a little bit more about nth root, read a little bit more about whatever function we want to use. Notice you can do that for gravitational force. What it does is it pulls up the help text lines from that function. So here is all the text that I included inside of my function file. So that's why we need that documentation inside of our function. Another thing, the command prompt down here in the command window, you can search through functions. If you click this icon here, it allows you to browse through and search through things like mathematics, what kind of math functions, exponents and log. So there's a lot of exponential and log functions that MATLAB has. So you can look for different functions based on interest. Another thing is the look for command. So let's say you forgot how to, I don't know, type what function you're looking for. So you can look for sqrt and be like, okay, I know it's a square root function, but I don't remember which one it is. So maybe there's more than one. So it'll look for all the functions that have sqrt in. You can see there's multiple square root functions. We look at this one, you can click on it, it'll print out that stuff. You can also do doc square root, and it'll open up the documentation. Same thing that you would see if you clicked on the help icon, which exists up here. You can also search that documentation up here. And then lastly, you can use help. So help gravitational force. It prints out those help text lines directly to the command window as opposed to right-clicking. Same thing if you did help tan-d. It'll print it out directly, whether or not it's a built-in MATLAB function or whether or not it's something you wrote. So there's all the different ways that we can find information on functions that already exist in MATLAB and for functions that we write ourselves. So this week in lecture, we are going to spend lots of time writing functions. We'll do activities for understanding that separate workspace and calling functions and all of this stuff regarding functions. We're not going to spend a lot of time on script files, but we're going to do heavily on functions.